All right, good day, everyone. This is Straight with the Cloud Pass Virtual Group. Today, our presentation is SSIS DevOps with Azure Containers. And our presenters are Elizabeth and Sreeja. Before we get going here today, I do have a couple announcements I want to run through, and then I'll hand things. Now, if you haven't yet subscribed to the virtual group through the cloud.pass.org website, I do recommend doing so. We do occasionally have changes in the schedule, such as this past Tuesday when we had a presenter that had to reschedule. And so that's the best way to find out about those kinds of changes and, of course, new sessions that are coming up. New sessions, we do have a number of sessions coming up over the next few weeks going through to the end of the year. And so there's a lot of opportunity to continue about building out Microsoft data platforms in the cloud. If you are interested in presenting, I am looking for presenters all the time. So if you are interested in presenting, just send me an email. You can email me at cloud@pass.org, or if you want, you can go out and fill out the form that's out on the cloud.pass.org website. And that's just a Google form where you can type in all the abstract information, and then we'll get your session scheduled. This fall, and actually just coming up in, I think, just about a month now, is Pass Summit 2019. Pass Summit 2019 is pretty much the biggest Microsoft data platform event that is around. It's a great opportunity to learn a lot about data platforms, both from Microsoft and from folks that are using technologies every single day. If you are looking to register still and you have not yet, you can save $150 on registration by using the discount code for this virtual group. That discount code is there on the screen. If you don't want to write it down right now, but you do want to get it, you can just send me a chat and I will send that out over the Q&A. This virtual group is virtual groups that PASS helps to support. These focus in on different areas such as language, so there's a global Hebrew, global Italian, or different areas of data platforms like DBA fundamentals and performance. There's a lot of opportunity between all of these, and these virtual groups, between all of them, there's probably 5 or 6 sessions that occur per week. Throughout the session, you may have some questions. If you do, please type to the Q&A panel. Throughout this session, if there are some questions that come up that fit the time that we're at, we may ask those, or most of them will probably end up being held to the end. And with that, I'm going to hand things over to Elizabeth and Sreeja and give them an opportunity to present their topic today, SSIS DevOps with Azure Containers. So let's make them.
Wonderful. Thank you so much. We are going to get started. Can you hear us?
All right. Yes, I can hear you, and you should now be the presenter.
Okay, great. I am going to share my screen. That is a good view. Hold on, sorry. I just was able to share my screen, and now for some reason I can't find it. Oh, there we go. Share my screen. Monitor 2. So thank you all for having us on today. Sreeja, Andy, and I will be speaking at PASS Summit this year. We're going to be talking about this, and hopefully when we get to PASS Summit, we will have actually a fully working demo of what this might look like, what our on-premises CI/CD pipeline for SSIS looks like. But today, yes.
Never mind. Your screen just finally came through. It was running a little bit slow there for coming through, but we do see it now.
Awesome. But today, what Sreeja and I will be talking about, and Andy is not here today, but we will be talking about how we set up our SSIS DevOps on premises, and we will be talking about some of the challenges that we've encountered by moving our DevOps pipelines into the cloud. So we don't have a fully working demo, full transparency. We do not have a fully working demo for this. We have a lot of things that we can report on, things that were difficult. And we'll get to that at the end, and maybe you all will have some ideas for us. So with that, let's go to the next slide. Yeah, we're actually going to show you some of our PASS Summit deck. So my name is Liz Barron. I'm a Senior Managing Director at Teach for America. And I'm here today with Sreeja.
Hi everyone, my name is Sreeja Pullagura. I am the Java Tech Lead at Teach for America, and I am also the DevOps practitioner at Teach for America.
Thanks, Sreeja. So Andy is not here today, but we're going to persevere and talk about our mission and our team. So why is DevOps important to us? Why is CI/CD important to us? It's because we want to do the absolute best we can for the mission of Teach for America. I have been at Teach for America almost 10 years, and Sreeja has been here almost 10 years. And we believe deeply in this mission, which is to find, develop, and support this diverse network of leaders so that we can work together to end educational inequity. And for those of you in the US, you may know about this already, but in the US alone, 16 million children live below the poverty line, and twice as many of those children are children of color, and only 14% of children growing up in poverty graduate from college within 8 years. So those are pretty stark numbers when it comes to the future of the US. And so we are here to hopefully end this educational inequity. What does our team consist of? Our team is actually really big. It's more than you would just consider database developers. We have the data platform team, which is database development, integration services development. We have data infrastructure operations, which you might maybe more the traditional database administrator role, but obviously an expanded role given our DevOps and our move to the cloud, or in progress move to the cloud. We have our DevOps team led by Sreeja, and we have our WinOps team. And only with all four teams working together as one team have we been able to find any success. So when we think about DevOps and we think about what we need to do for our mission, it really is very much coming together in a different way with a different communication style, potentially different platforms to get to where we need to be for our mission. So Sreeja, can you talk a little bit about DevOps and our vision, please?
Yes. Okay, so let me take you all back to 2017, where Liz and her team, they started working on a project. It was a really non-negotiable deadline and really critical for the business team as well. And at that time, Liz, with her great vision, she has proposed that we should all embrace the miracle of DevOps. So what did she mean at that time? She wanted to have better code quality by having unit tests and having artifact management, so that when you finish code deployment, package it, and build it, they are stored in an artifact repository. And then have code reviews, so that when a developer works on a functionality, the fellow developer would review that code and also provide feedback into any blind spots the author of the code may not have seen. So if I'm working on a feature and Liz reviews my code, she might give some advice on how to make it better, how to make it more bug-free. So that way we both learn. And also if I'm out of office or not available for some reason, she would be able to take over and continue that code. And that means you can see with unit tests and better code reviews, we are identifying any potential issues way earlier in the process, which is called shifting left, which will give you the benefit of lesser expensive issues and bugs, and you are not at the risk of finding show-stopping issues close to your production release. And then we wanted to have automation for the builds, unit tests, deployments. So people are not waiting on this one highly privileged developer who has all these admin permissions to do your builds, run the unit test, do the deployments. Basically take all of that dependency out of this person who historically somehow seems to have access to many servers, and make them also free. and make them also have fun writing code and contributing to the project. So we automated all the builds, testing, and deployment. We'll show some of that in our demo later. Where are we getting with all of this? Continuous integration and continuous delivery. CI/CD stands for that. That means very high value and quicker delivery. This came with a lot of culture change and the teams unlearning old development practices and learning new ways of coding and using DevOps tools and practices. By the end, they saved so much time that they all said it was worth it. In the end, you have happy developers because everybody knows where the code is, everybody kind of reviewed others' code, and the builds or tests are automated, the deployments is automated, and you have higher confidence in your product. And as a result, the business is also happy because you have a better quality product. This was what Liz achieved by embracing the miracle of DevOps back in 2017, and we are still continuing and doing even more fancy stuff now. We'll show those as well. That's what we meant by the miracle of DevOps.
Thank you so much, Sreeja. And while I've been given a lot of credit by Sreeja for this, it really has been a team effort. We have across IT, again, those 4 teams that we talked about, if it were not for those 4 teams coming together regularly to swarm on issues and to make our vision come true, there would be no possibility of it actually working out. So this means our tech leads, our database tech leads, our SSIS tech leads, our DevOps tech leads, people that support the DevOps tech leads working long hours to figure this out, because it wasn't particularly easy. I don't think a ton of people are doing this. So I want to talk concretely about the CI/CD vision, the continuous integration, continuous delivery vision. What does this mean specifically for us and specifically for our data platform? If you look at this, you'll see that there's a lot of nice looking icons, and these are the tools that we use. Looking back on this, I think some of our tech leads may have reflected and say, actually, we probably should do things a little bit differently. And that is also part of this iterative vision that we have. This did not look this way 2 years ago. And in 2 years from now, it's going to look completely different again. So what is the CI/CD vision? Really, it's this top row here. We need the code reviews and the test-driven development. That's the shifting left that Sreeja was talking about. We're storing our assets. For SSIS, that is your ISPAC, your ISPAC files, your DAC packs for our unit testing databases, which we'll get into in a little bit. Unfortunately, there's no SSIS static code analysis, but we can dream. This is our vision. And our unit tests. And then finally, all the way to the right, we have the automated deployments. Again, taking the manual labor out of this, taking the manual mistakes and the errors potentially, also the blame. If it's automated, you know exactly who did what, when, because it's all audited. So let's start back on the left when we talk about code reviews and test-driven development. This is how we do it on premises. This is not necessarily how we'll do it on the cloud, although I think there's a lot of overlap. We use Bitbucket for versioning, which is Git, right? So that's where we have our centralized repository for Git. We use Visual Studio, which is especially 2019, I've been really impressed. Visual Studio to clone our projects. And then when we want to get them back into Bitbucket, we use pull requests to get back into our main branches. For us at Teach for America, we've decided to have environment branches. So that means that our environment dev branch should match pretty exactly what's in development. Same for QA and same for master for production. When we get this pull request and it's merged, we have this tool called Jenkins. Jenkins is this gentleman with the towel over his arm. And that's our automation and orchestration tool. So Jenkins, through a webhook, picks up the changes and runs some pipelines. So Sreeja will show you exactly what that pipeline looks like. But basically, we run a pipeline, and in that pipeline, we have this ISPAC file that's created, or DACPAC files, and we do 3 things. We go ahead and store our assets in Archiva, which is great for that. And in some world, which we don't have now, we would do the static code analysis. And then critically, we have this huge whale, which is Docker. running TSQLT. If you haven't heard about TSQLT, it is fantastic. It's test-driven design for SQL Server. Sebastian Miney created it. I think there have been some other contributors. We actually have a contributor on our team, Rong Chen, who's made significant changes to it to allow it to run SSIS unit tests, which is what we needed here. So Docker is a containerization technology, and we use that to run the unit tests in an isolated environment. So those three things are kicked off. And finally, if all goes well, we don't have any major breaks or unit test issues, that asset we have is deployed to the correct environment. If it's the environment development branch, it'll go to the dev database, et cetera. And if it's master, it goes into production. So this is how we've envisioned, although we continue to work on it, our own CI/CD pipeline internal to Teach for America. And this is all on premises. The trick is really how do you get it to the cloud, right? So we're going to do a couple of semi-live demos. Are you logged in? Do you want to do the first one?
Yeah.
So the first one, we're going to talk about our on-premise or on-premises. I don't know which one it actually should be. But we are going to, and I think actually PRJ Education Dev works really well. Vlad Filipovich, if you're on the phone, either thank you for fixing it or thank you for ensuring it continues to work. So we have, do you want me to give you the link?
Yes.
All right. So I'm going to stop screen sharing and have Sreeja share her screen. So how do I do that? Hold on a second. I am going to stop showing screen. Great. And you should be able to, yep. Do you have the?
Yep.
Great.
Okay.
So just a minute while it takes just a second for this to come up, but there, that's perfect.
Okay.
All right, take it away.
Can everyone see the screen I'm showing? I'm showing
I can
the-
see it, so you should.
Okay. All right. Thank you, Liz. So this is one of our CI/CD pipelines for one of our SSIS projects. SSIS stands for SQL Server Integration Service. And Liz, with her vision, she wanted to have continuous integration and delivery for SSIS projects within her team. So we started working with her team, like I said, 2 years ago, and we identified, okay, what are all the pieces that have to come into place to have this a reality? So they first started with version control, and I'll go through all these green blocks you are seeing. So when we run this pipeline, it executes all these stages, which are the pipeline stages in Jenkins terminology. So what's happening here is in the first step, on commit to our code repository, Liz has taken a lot of effort in bringing her team up to speed with version control practices. So now all their code is versioned. And if your code is not versioned, I would say first step, please do that. It'll save you all a lot of time, effort, and pain, and not losing any of your work or be like, hey, this worked on my computer last week, but my computer crashed. Now I don't know what I did. I don't remember. All those things would be gone. So as I mentioned, our code is in Bitbucket, which is our version control tool, and we configured the version control repository in a way that on any commit to the code, the Jenkins job would be triggered. So this job you see here on the left, let me show you, has been run around 70 times already, which is a small number. We have some jobs which are run in thousands of times. So on code commit, the pipeline starts, and then it installs any required tools. And then in the poll SEM step, it would do a git clone, get the latest code within the workspace of this project. And then that's the SSIS project. So we want to build the latest code, and we have the necessary tools installed. So we build the ISPack. ISPack is the artifact, which is package, which is the output you get after building the SSIS project. You can open it using any zip util on your Windows computer, and the contents are XML files with project related information. And then we publish the ISPAC to Archiva. As Liz and I mentioned before, Archiva is our asset or artifact management repository. Once we build the code, we want to store it somewhere so that, for example, someone in Liz's team wants to know what was our code 2018 June 1st. So we can go back, look up for that timestamp and get that exact artifact. And you don't have to revert or roll back any changes you have done from last year to now. And then we build the unit test backpack. Liz would show more about the unit test project. The whole point of this pipeline is to have unit tests run for your project. So they have developed a project within the SSIS solution, which will have unit tests. And then here we set up the Docker container. So a quick plug about the Docker containers. They provide this isolated environment with everything included. Of course, you have to write your own Docker file to build your own container, which is not difficult. We were able to set up many for our own requirements. So here what's happening in this stage is we are setting up a Docker container for SSIS unit tests. What does that mean? Imagine your own server with just SQL Server, SSIS installed, no other tools or infrastructure, and an admin user who has all the privileges in that environment. So basically you're having your own isolated environment which things only required for unit testing SSIS projects, and you're bringing it up on demand. It's not your development, it's not your QA, it's not any of your live environments. And we are bringing this up on demand when the pipeline is run. So each of these builds, they are bringing up their own containers. Everything is separate. For build 39, it has its own container. For build 40, it has its own container. Sorry, it's 6970. So we have the Docker containers here. And now the SSIS project we want to test has dependent projects. It needs other SQL Server projects. Because we have all our DAC packs, artifacts on Archiva, we can just pull it from there, download it from there, and then we are deploying that into the container. So here, first we deploy the SSIS package we built in this step. Then we deploy the DAC packs, which are the SQL Server projects, which we got from Archiva. Then we run the unit test. That's the TSQLT unit test Liz talked about before.
If you open up the log files, you can see that because it's waiting for you to proceed it. But if you do that, if you look at the log files before, you can actually see those unit tests. I don't know if that's something you want to do.
Yes, yes. So let me go into the console. Okay, so this is a quick summary of all the tests we have in that project, and it says success, so all tests passed. For that build, which we run in an isolated environment and using all the latest code we have from our version control. And let me also show you this test result trend. You would see this red blocks, which means there were some failures before. And in the beginning, there were so many failures. Build 39 had 8 failures. We eventually brought it down to 0, and someone made the code change again. It went to 5 failures, and then they fixed it again. As we are making changes, some tests are breaking, but they are fixing again. That is continuous integration. Like any code change is not left untested. And the container is now up and running, all the tests are run. However, as a developer, as a tech lead, you want to go and see, hey, I have this one suspicion, or I'd like to know more what's happening for this particular use case. In this case, you can see it's still waiting for user input. It didn't clean up anything. So we have that facility for the developers to go into the container and do further manual checks if they need. And if they don't need anything to be verified, as you can see, it shows a box. So you clean up the container. That means it's cleaning up all the Docker environment which was set up for this build. And now it's pushing the SSIS package to the desired environment. So by the end of this, we verified the code, the latest code, using the latest artifacts from Archiva. And we also tore down the temporary environment. We set it up. And if you look, the whole thing took around 7-8 minutes. And the additional few minutes, it was waiting for user input. So imagine having this every time you make a code change, and you are having better and better code quality. As you can see, the yellow indicates there were failing tests. There was a lot of yellow, some green, and something really went wrong here. Then we are back to green again. So our health is tending green. That means Liz can confidently tell to business that, hey, we have a solid product because we assure you through these pipelines and test results. Any questions, comments?
I think we'll do them at the end.
Okay. So Liz, please take over.
Sure. If you'll let me share my screen, I will. I will show you, I'm not going to show the packages necessarily, but I'm going to show you a little bit about the unit tests because I feel like the packages are pretty straightforward. What we have here, I'm not sure if everyone caught it, but when Sreeja showed us the log files, she showed us 9 unit tests that we're passing. Let me just move them over so you all can see the 9 unit tests that we're passing. This is the same log file, and you see I actually have 9 unit tests here. They all were executed and they all succeeded. We have 3 in the audit, so we're testing 3 different things in audit, 2 different things in Delta, and 4 in our upsert. So let's look at audit. We're doing this, we're testing that the Delta record inserted into audit when any one value difference between our source and our target. So that means that our Delta is working. Like if this is not true, then we have a problem. That we land only the changed records to the audit table, and that our SQL query fields actually map correctly. Some of these might be redundant. This was in some of our early unit testing, but this is basically what we're going for. Like, did we mess up our mappings? Is something not loading right? How is audit? What's the health of audit? If these all pass, the health of audit is pretty good. So what do these actually look like? And again, Sebastian mining with TSQLT is fantastic. This here, you'll see, is those same exact tests. They're all in the form of stored procedures. And the way that we package them in our solution is that we have PRJ education is the SSIS project, and it has a sister project, this PRJ Education UTDB, which is a SQL Server database project. This is an SSIS project. This is the database project. In that database project, we import TSQLT, and then we create these stored procedures. So the first stored procedure, I think, is, let's look at this one. Yeah, audit load. So let's look at this one. With TSQL, let me just make sure I'm opening the right one. TSQL, and this really is TSQL code, right? We are creating stored procedures. Those are the unit tests. This stored procedure is going to internally run our SSIS package. So we're setting up some package details at the top, including our package name, project name, folder name. These are required. Execution ID, we have to pass in as an output variable. Reference ID, we have some logging levels. These are all related to how we actually do the mechanics of running our SSIS package. We have some project variables. some package variables, and then we set up our test data, right? We have some data constraints, or constant rather. We have the record count. We have today as a string, just some things to make the testing easier. And then we set up an original record, and we set up an updated record. And the point of this test is to make sure that there is a delta record inserted into audit when any one value differs between our source and our target. That's basically what it does. So we're going to be testing to make sure that anything in this original record, if it's different, it better get into our table after running our SSIS package. So we've made some changes, like for a specific record, the GPA is different. For another record, the range is different, the major is different, et cetera, et cetera. We create a fake table. Again, TSQLT is awesome. It allows you to do this sort of stuff. We have a fake table audit, and we have a fake table, which is actually a view. We go ahead and insert. I know this is going to sound funny, but because we faked the view, we can go ahead and insert into the view. So we have these insert statements. They are dynamic SQL because you need to use dynamic SQL with certain types of views, and that was the case here. So I'm just going to blow through this a little bit. And then here, as it says, step 2, run the SSIS package. So those variables that we declared at the top, they're being sent in as parameters, whether it's the folder name, project name, or whether we're sending in the project parameters. Those are all going in. Critically, we create the execution. We set up the execution parameters, and then we start the execution. The reason that this is possible in TSQLT is because, again, Rong Chen and others on the data platform team worked hard to make sure that TSQLT could run outside of a transaction. Right now, the magic of TSQLT when run against a database is that it runs within a transaction. You cannot run SSIS packages within a transaction. It just won't work. So some changes were made. You can run it outside of a transaction, so you can actually do this work, which is just magical. It's just magical. So we are going to create 2 tables, expected results and actual results. We run our SSIS package. We should be able to go ahead and put the expected results in our expected results table, and we're getting those from the values we determined above. We go ahead and put the actual, like this fake table here, we did fake this table. Once the SSIS package ran, it populated this table. We're getting the results and putting them into the actual results table. And then we're using this TSQLT assertion, assert equals table, to ensure that they're exactly the same. So this is a great way to test if every single mapping works, or if every single value is different, you actually get those records back. And once you've done it once, even though it's a little bit to set up, like that's the last time you do it. You just make sure your tests continue to run. So this is what the unit tests look like for SSIS and are critical to making CI/CD work, to ensuring that we all feel comfortable actually deploying out to our target environments, which is what Sreeja showed you. So with that, I do want to get into the cloud, or do we have other things you want to show? Okay, so let's talk a little bit about the cloud, because the cloud has been difficult. That was our on-premise demo. The Azure cloud demo, let me tell you what I wanted to show you. Not a ton probably is that different. Like our actual vision doesn't change significantly when we talk about what's the difference between our on-premises vision and our cloud vision. We're still going to use Bitbucket, I assume. We might use GitHub because that's a cloud version, or maybe Azure DevOps projects. That's another possibility. Automation, we've looked into Azure DevOps. It looks really great, but there are some immediate problems with Azure DevOps, and that it's not possible to build SSIS projects without installing unsupported extensions, which I'm not a fan of. The other way to do it is so in Azure DevOps, you're given 10 agents by Microsoft, and I think it might be possible on one of the agents, because it's a Visual Studio 2019, to perhaps download the correct marketplace extension and use that to build SSIS projects, but that was complex and I couldn't figure that out, at least not yet. The other thing that we're looking into doing is creating a Dev Test Lab VM so that we can have it auto start and auto shut down, because we own all the licenses, to actually install the agent software onto that dev test dev test VM and do the build there. But again, it's Azure DevOps. You can do it. It's just going to take a lot of work. I think Andy's going to have some interesting things to say during the past summit about how that's getting better. So those are the two ways we know of right now, and we're working on that. But then really what it comes down to, for me, is this part right here. Like, how do you get containers up and running, especially Windows containers, which is what we use because we're using SSIS. How do you get that up and running on the cloud? Our intention is to move to Azure, which is the Microsoft cloud, as you all know. But Azure container instances, for the past year and probably a lot longer, it's really tough to use them because the way that they're built right now is that there's one Windows container per VM when you bring up an Azure container instance. So you go into the Azure container instances, you specify the container image you want, you press go, and what happens on the back end is a VM is spun up, it has a container host software on it, and then it spins up your image. On the Windows side, they allow one image per VM, which I think if we think about like just resource usage and resource efficiency, that seems really inefficient that they're bringing up an entire VM for one container. On the Linux side, it's written differently. On the Linux side, you can have an Azure container instances, multiple images, all running in the same Azure container instance, which is fantastic. And I think that if, as we go forward, and we are definitely, I've been talking to people, I've been sending emails to Microsoft about how this is going to be changed. But the way forward, I think, is to actually use Azure container instances. But right now they don't work. As you see our pipeline, we're not going to wait 30 minutes just for the container to boot up. 20 minutes is long enough. People complain about 5, and they want to do work. They want to get things done. 30 minutes is unreasonable. So instead of Azure container instances, we're looking into the Azure Kubernetes service, which some may say is like taking a hammer to, I don't know, a needle, given how robust that is compared to our use case. But there really doesn't seem to be another good way to bring up containers, especially Windows containers on Azure. So let's talk a little bit. Well, let me show you what we have. Why don't we just show you what we have? So in the Azure Kubernetes services world, let's see, here we go. So we have brought up, yes, I would like to reconnect. I would like all the things. All right, this is going to throw me some errors until I fix it. Here we go. Let's go to Kubernetes. So you may know that there's something called a Kubernetes service on Azure. When you click add, this gives you your normal Kubernetes service, which at the moment does not support Windows. And when I say it doesn't support Windows, I mean, unlike this particular preview Kubernetes service, when I click on my node pools, you will not have something called Windows here. The only thing that will be allowed is Linux. So the regular vanilla Kubernetes service, you will not see this. You have to turn on a preview feature, which we've done to create this particular Windows node pool. I am super new to Kubernetes. I am new to it to explore this as a proof of concept to see if we can get this done while we wait for ACI, Azure Container Instances, to be updated or rebuilt or whatever else needs to happen. So I will give you a very brief, oversimplified version of what I believe Kubernetes is, which is that Kubernetes is basically an abstracted container host with a lot of fancy features on top. So when I say container host, a container host is something like Docker, where you install it on a VM, and if you give it an image, you can make that image go because that's what it's for. You can build images as well, but really is to make those images run, and you can have multiple images up at the same time. What Kubernetes does is allows you to group images in group containers really in pods and basically call that an application. Like this pod really defines like a service or an application itself. It's multiple containers potentially. It's one or more containers within what's called a pod. Those pods run on nodes. In the more, I guess it's not even physical world, a node is basically one-to-one with a VM. And those nodes might live in a node pool. And so a node pool is a collection of nodes or VMs. So when you talk about Kubernetes, your smallest unit is the container. You have one or more containers in a pod, you have one or more pods in a node, and you have one or more nodes in a node pool. For this particular preview version of Azure Kubernetes Service, you can have up to 400 nodes across 8 node pools. I think in the unrestricted non-preview version, you could probably have more. So this is, again, super robust. Like, you can do a ton. You can run your production systems. People do it. I wouldn't run your production system on the preview version that allows Windows, but it's up to you. So we got this up and running. We have a Windows node pool, which means we have a Windows node. We have exactly one Windows node. That means we have some place to run our Windows container. And we actually have a Windows container, which I think we want to walk through a little bit. Do you mind walking through the Docker file?
Yes.
Do you want me to put it up here, or do you want to share your screen?
Present.
You want to present? Okay.
I mean, it's the same file.
Okay. So Sreeja's going to walk us through. Oh, sorry. Can you reshare this? Okay, you can do it if you want to. Do you want me to send you the link?
Yes.
Yeah, I sent her.
So Sreeja's going to walk us through. Great, thank you so much. I don't even know if this is. Here we go. All right. So Sreeja is going to walk us through the Docker file, and she's going to explain more about what a Docker file is, but it's the base unit of how you get a container image up and running, or a container image defined. So please go ahead, Sreeja.
Thank you. See my screen?
Yes.
Okay. So this is the Docker file. Quick step back. A Docker file is a plain text file like this, which is normally short, around 80 lines, and you build Docker image out of the Docker file. So in the Docker file, you specify all the configuration for the Docker image, and Docker containers are instances of the Docker image. Previously in the pipeline, when I showed you that we set up a Docker container, and I told you guys we'll be having SQL Server and SSIS installed on that. This is the code behind that. What we did was we have a Docker file like this. It's available on GitHub. You can go and access this URL to see or refer after this presentation. And within this, we have all the instructions to set up only the things required for running unit tests for the SSIS projects. So what do you need for that? You need SQL Server. And to run SQL Server, you need Windows. So when you start from line 1, you see, okay, first, huge thank you to Microsoft. We started by referring to this Docker file for SQL Server Windows by Microsoft. That's also on GitHub at this URL. A lot of this is Microsoft's file with additional enhancements for our requirements. I'm going to highlight both. So line 1, when it says from that URL and the tag number, it means Docker would get the base image for Windows Server Core from Microsoft. And then label is the name of the maintainer, that's me. And we have arg, which is the build arguments for building the Docker image. So when you are building the image, you can specify values for these arguments, where to get the TSQLT DAC pack and where to get the AdventureWorks, that's the sample project DAC pack.
Can you talk a little bit about that TSQLT DAC pack URL, because it's an Azure URL and you did some special things to set it up?
Yes. So you would see the URL says pkgs.dev.azure.com. What we did here is, as I showed earlier, all our artifacts are in Archiva, but our Archiva is only available within our organization. We do not expose that to public. It's organization confidentiality policy. However, the TSQLT backpack we want to show you, so we put it on Azure Artifacts, and this is the URL to download from Azure Artifacts. You can see it's in the Teach for America namespace, but you want to play with that, feel free, go ahead to this URL and you can download that. We don't have any organization specific information in there. And how I pushed it to Azure Artifacts using the Maven command line. We have the artifact within our organization, so I created a Maven project and used the Maven command line to push it to Azure Artifacts. Then the env is the environment variables for the Docker container. These alphanumeric links are the setup files we download for SQL Server. And then we are having an environment variable for SA password. We started with the very basic welcome one, but we don't want it to be super easy to guess. And this is also configurable. It says this thing, you can copy, paste, and try it out, but it won't be this every time we are building because we would be passing different values. And this is some setting for PowerShell, and we are giving the work directory as the root. Here we are copying some PowerShell scripts and DAC packs into the context. The names are pretty explanatory. Deploy DAC packs is the PowerShell script to deploy the DAC packs database projects. Change SQL login. We had to write the script to change the SQL login for SA user. What we noticed was every 30 days, the SA login password used to expire. And suddenly after 30 days, all our pipelines were failing, saying that password expired. And it took us some time, and later we thought, okay, we should turn off the password expiration policy, and that is wrapped into the script. Then we have another script for setting up SSIS. It does all the things required for SSIS, such as enabling the CLR integration and setting up the SSIS DB catalog. If you are familiar with the SSIS development, these would ring a bell. If not, these are basic required for SSIS projects. Then we are copying the master.dacpack and msdb.dacpack. These are some of the dependencies. And here, these lines were available in the Microsoft provided Docker file, except we added this additional feature for IS. Why? Because we wanted SSIS integration service available on the SQL Server. The Microsoft Docker file did not have this on, but Liz has the vision of setting up SSIS inside the container, so you put the IS feature. And then we are cleaning up any setup files. And like I mentioned, we want only the things necessary in the container. Keep your Docker images, Docker files as lean as possible to avoid any chances of other dependencies potentially affecting your test results. That way you will be assured that given the basic required configuration for your project, running the tests, if everything is working and something is broken in the other environments, maybe there are external factors. You can start debugging in that fashion. Then in these lines, we have added this to download the DAC framework.msi because we wanted to deploy DAC packs within the image when it's built. Quick sidetrack. Initially, we did not have this, and our teams were deploying the DAC packs after the container was built. They had to wait like 4 or 5 minutes, which is not bad, but we want even faster. So we added the DAC framework MSI to get SQL package, and now 5 minutes per pipeline is saved. So multiply that by the number of developers in your team and how much more unit tests they can run and how much more happy they are. We have this additional scripts for SSIS projects, which are called by the setup SSIS script. Like I mentioned, you create the SSIS catalog that happens in this script. Then we enable CLR integration. This is the script for deploying SSIS package. Here we run the change SQL login command, which means it's changing the password to what we provide. The default is what I showed above, but every time a container is set up, we can provide a different value so that it's not predictable by other users. Then we set up the SSIS components by running this command. This was all custom, which we added on top of the Microsoft image. And this is also custom. What we are doing here is we are downloading the TSQLT DACPack URL from our Azure artifacts, and then we are downloading AdventureWorks pack file to set up the AdventureWorks sample project. And also we are deploying DACPacks because there are other dependent DACPacks. The ones I showed earlier, for example, these two. So now we have all the DACPacks available. Here there is a step to stop the service because while building the Docker image, it internally starts the containers. So this is the step to stop the SQL Server. This was provided in the Microsoft website. We wouldn't have figured out had we started all this from scratch. Then we have a health check to see the health of the container, which would be running SQL command. And if it returns successfully, meaning the container is up and running successfully. We wanted OpenJDK. In here, we do not have WireMock, but for our internal projects, we use WireMock for setting up mock data for certain APIs. Hence, we are setting up OpenJDK. And here you would see Choco, stands for TSQLT. That is the package manager for Windows. And it makes the setup one-line commands like this. So you don't have to do anything elaborate for setting up OpenJDK. All you have to do is run this one command called Choco install OpenJDK, and everything else is taken care of. We are copying the start script. Then we have this additional step for creating a new local user, and we are giving that user admin privileges. Then the container would be run as the local SQL Server user. And we are running the start command with all these argument values. So when you say Docker run this image name, it would start from the start command and it would be running as local SQL Server. On successful run of the Docker run command, you would have a Windows server because you have the base as Windows, and then you would have SQL Server because you are setting that up here, and then you would have SQL package because you have the DAC framework. You would have changed the SQL login, install TSQLT DACPack, install the AdventureWorks pack, TSQLT, and OpenJDK. Everything wrapped and packaged into one box, which is all yours to do unit tests. That's what you would get by running Docker run on the Docker image. And after that, you could use it in the pipelines like I have showed in the demo earlier.
Thank you so much, Sreeja, for walking through that. What I would love to do in our final couple minutes is show just the very basics of what we have set up in Kubernetes. It is not fully working, unfortunately, but if I could share my screen, I will show you all our Cloud Shell. You may have to stop sharing. I'm not sure. Okay, there we go. Perfect. Thank you, Jason. So I'm going to start sharing my screen again. And you see I'm in the Azure portal. I have opened up Cloud Shell, and I have switched to the appropriate subscription using AZ account set. I have set up my Kubernetes control, so kube control or kube cuddle, to hit my specific service. And I can prove that by typing kubectl get nodes. And you see I have two nodes. I have my Windows node and I have my Linux node. The reason you must have two nodes is Linux is where Kubernetes runs, and then the Windows is the extra one. And if I do kubectl get pods, I actually have two pods running too, and these are in my Windows pool. There are two Windows containers, one of each, and the file that Sreeja just went through, that is actually what formed the images that Kubernetes is using to bring up these, I lost my thing, but that's okay, to bring up those containers. So what do those containers look like? I think I'd like to show you here critically. This is our Azure Container Registry. It's private to us. It's not a public container registry. It holds the container image. It is on Azure. We love Azure Container Registries. And if you all want to somehow figure out how to get into my databases there, I welcome that challenge because I have yet to get into them today. So here's my password. If you can do it, let me know, send me the details, because I've had trouble today. So what generally you want to do though for Kubernetes is you're setting up your container images, you put them in a container registry, you define a deployment. So this is my deployment file, it's a YAML file. It tells things like, hey, here's my image that I'm going to bring up. I would like at any one time, I want two of them. I want two containers up and running. Some environment variables, so the SA password that Sreeja was talking about, I have reset it to something else. Again, if you can get that working, I will be so grateful. Another interesting thing here that you might notice is these two lines. So these are, node selector is what kind of node can this container run on? How do I want my application to run? So some nodes might have specific things like higher GPU or GPU at all might be on a specific node. And so you may configure that for a specific type of node. In this case, we are configuring it for a specific type of node. We're saying, please don't try to run my Windows container on a Linux node. It must be run on Windows. And as you can see, this is a beta parameter or a beta field. I set up my Windows and that's it. And because this is SQL Server, you'll notice that 4 gigs of memory is set up, 300 megabytes here. Like the CPU and memory is pretty high. But that's the basics there. Then what you need to do to actually hit these is you need to set up an endpoint. So I have set up an endpoint. This is an internal IP address for one of my pods. And you can see that because I can set the output to wide. And you'll see here that here, this pod down here, WinCpool that ends with 8811 or 8L maybe, the internal IP address within Kubernetes, within its node, is 10.240.081. And I have set up an endpoint that says, hey, you should actually be able to hit 10.240.081 on the default port for SQL Server. So I've opened that up. That's my endpoint. Then the next thing I did is I set up a service, a load balancer. The load balancer was what allows the rest of the world to get into your Kubernetes service. So I've set one up, and I've mapped port 21.433 to 1433. So I should be able to, if this is set up properly, which, gosh, I thought it was, I really did. Here's my service. You see that here is the external IP. I should be able to hit this external IP with this port and actually with SSMS and get to my SQL Server. So I'm going to do a little bit more digging here. Is it details? Describe. It's describe services. I should spell that correctly, otherwise it just won't work at all. Describe services, Windows container service. Copy, paste. This should give me a lot more information, and it does. So my load balancer ingress, that's the IP address that you're going to use to get into your Kubernetes service. This is the port, right? That is the port, and it's mapped to this target port, 1433. So all this together means that I should be able to bring up SSMS, and sadly this does not work. Otherwise, it would be amazing. I should be able to connect my database engine. I should be able to, let's see, copy this here. Copy. And I should have port 21.433. I should be able to use SQL Server authentication, SA password. Let's go find my SA password. Here it is. Oops. Let's see. And connect. And this is just going to sit here until it errors out, unfortunately. But that's the idea around getting your Kubernetes service up. And what we plan to do next once this is up and running, which we're going to figure it out as soon as the demo is over, I'm sure. We'll set up namespaces, and namespaces in Kubernetes basically creates fenced off areas for your different containers. So we're going to create a fenced off area for developers so we can have developer databases in there just to do your development, and then another namespace for our pipeline so that those two don't cross. Because wouldn't it be sad if you had a pipeline that used your database and then deleted it? Like, that would be the worst of all possible worlds. So we're going to stop here. Thank you all so much for your attention and time today. We would love to take any questions. I know it's 2 o'clock, but if people have questions, we're here to answer them either right now or by email later.
All right, excellent. We do have one question. And so we probably have time for this one. Do you always have to wait for user input to proceed after the unit test for clearing the container before deployment to an environment? Like, isn't there a way to automate it so that if all tests pass, they can just deploy without waiting for user input to proceed?
Absolutely. That is actually written into the Groovy code for our Jenkins pipeline. You do not have to do that. That is specifically so people could, because we're at the beginning of this and sometimes unit tests fail, it's so that people don't have to run the pipeline again and wait another 6 or 7 minutes to get to the container and potentially do some debugging. That's the only reason that's there. But you can absolutely take out that step if you feel confident, if you got your unit tests in line, if you don't need to worry about debugging, your containers are fast, by all means, you should take that step out.
All right, excellent. Well, thanks here today. This has been great for, well, definitely for myself and hopefully for everyone that attended. Thank you for presenting.
Thank you so much. Thank you so much for having us.
Thank you, Jason. Thanks everyone for joining, and please send us feedback if you have anything after this presentation. And yeah, if you're coming to PASS Summit in Seattle, please come to our session.
Yes, we will have this working. It's going to be awesome.
Yep.
All right. Thanks again, everyone. And with that, I'm going to close things out. And goodbye, all.
Thank you. Bye.